This is just a quick video to go over some of the functions of your BAII Plus calculator and a little reminder of how to calculate some of the variables in the present value, future value calculations. So whenever you're looking at present value, future value calculations, there are 5 variables and you can only ever solve for one at a time. The 5 variables are PV, which is present value, FV, which is future value, N, which is number of payments, and make a special note here, it's not number of years necessarily unless you have annual payments. So always think of N as number of payments. IY, I like to call that rate. I know some people call it interest rate per year. However, when we get into projections later, not all of the return that we generate is going to be interest. So with that in mind, I like to refer to the IY as the rate. And then PMT is the payment. So whenever you solve a future value, present value calculation, you can solve for any of these variables. We can find the present value or the future value or the number of payments or the rate or the payment. However, we can only do one at a time. The other 4 variables must be known. Before you even start to do a calculation, you need to ensure that your settings are the way that you want them. So by settings, I'm referring to how to change the number of decimal places that your calculator has, how to switch from beginning to end, and how to change your payment frequency and compound periods. So let's take a look at your actual calculator. Your BAII Plus calculator looks something like this, hopefully. And just a quick look over, you'll see that there are function keys along the top where you can look at N, IY, PV, payment, and future value. Those are the input buttons that we're going to be looking at. If you look at the printing above each button, you'll see that each of these keys, and these as well, they have second functions as well. So for example, this is parentheses and y to the x, but you can also look at the second function, which is sine, cosine, and tangent. So how do you access the second function? If I push this button here, how do they know if I want to use the parenthesis or if I'm looking to use the sign? This button right here. Now I know this is grayscale, but on your BAII Plus, I think it's a different color. It stands out. So to access, when you want to use, like find your N function, IY, you just press the button directly. If we want to look at one of these second functions, we would hit the second function key first, then hit the key, and we would access it. So first one, how to change the number of decimal places. We look, and that would be the format. So it's above the decimal place. So second function, and we hit the format, and we see DEC, which stands for decimal. And right now my calculator is set to 2 decimal places. Rule of thumb, if you're looking at dollars and cents, you're going to want 2 decimal places, but if you were doing other calculations, for example, mutual fund, net asset value per share, we would like to do 4. So if you just hit the 4 and then enter, and there you go. And when you clear, you'll see that you now have 4 decimal places. So I'm going to switch it back to 2 because our calculations today, we're going to be doing dollars and cents. So again, second function, format, and I just want 2 decimal places. And I'm going to put enter, and that will set it. How to switch from beginning to end. So what that means is when you're looking at a future value or a present value calculation, when does the compounding occur? At the beginning of the payment frequency or at the end of the frequency? Right now we've got the calculator, and you can see right here it says BGN, so it's set to beginning. If I want to change that, we look on your calculator, and there above the payment key is BGN. That's short for beginning. So second function, hit your payment, and it will tell you which one you're set to. If you hit second function again and enter, that's the set key. Now we've changed the setting to end. And if we clear it out, checking it, we see that it's now set to end. Second function set changes it to beginning, set again, second function set changes it to end. So right now, when it's set to beginning, you will always see BGN here. When it's set to end, nothing appears at all. So now the calculator's set to end, but if I wasn't sure, I could just check it like that. If I still want it set to end, simply clearing out leaves it without changing it. You still have to do second function set again if you want to change that. Changing your payment frequency and compound period. Sometimes you're going to want to look at annual periods, sometimes monthly, sometimes weekly, or bi-weekly, or even semi-monthly. So difference between semi-monthly and bi-weekly. Semi-monthly would be like the 15th and the 30th of every month, and there would be 24 payments per year, as opposed to bi-weekly, where it's maybe every second Friday, and there would be 26 bi-weekly payments. So to check how your calculator is currently set up, second function and that payments per year here, and I've got it set to 52 payments per year, which is a weekly setting. So if I wanted to change that to monthly, I would simply enter monthly, and again press that enter key to secure it. Your calculator will default your compound periods per year to align with your payments per year if you do nothing. So because I've set my payments per year to 12, my compound periods are also set to 12. How do we check to make sure we know what our compound periods are? Well, second function, PY the first time, or IY, which gives you the PY function because we second function, shows you, and then we just hit this up arrow here and we see our compound periods per year, which is defaulted the same. When might you have compound periods and payment periods differently? Well, a mortgage is a really good example. So for a mortgage, you might want your payments bi-weekly, monthly, or even weekly, but the compound periods year are normally 2. So in that case, say I wanted bi-weekly payments, I wanted to set up a mortgage payment for bi-weekly, I would say second function, payment per year, change that to 26, enter, and then I would set the compound periods per 2, and don't forget to click that enter and clear. Now if I go back and I want to change my payments per year to 12, be careful because your compound period, because you've changed your payment periods, your compound periods default. So if I was playing with a mortgage calculation, I would definitely want to check my compound periods every time. So that's how to change your decimal places, how to switch from beginning to end, and how to change your payment frequency. So now let's go back to our slideshow presentation and we'll look at an example. So here's a sample calculation. Let's assume we're going to purchase a car for $25,000. We have $5,000 saved towards the purchase, and we're going to finance the rest over 4 years. We've been told that our interest rate is going to be 9%. So first thing we need to do is, what are we trying to solve for? What are our variables? Present value, future value, N, IY, and payment. So which ones do we know? We know that the present value, so the initial value of the loan, is $25,000 for the car purchase minus what we have saved, being $5,000. That means that when we first take out this loan, it's going to be $20,000. We know that the interest rate per year is 9%, and we just got that right from our question. It's right here. And we know that N is going to be 4 years. Now, if we have annual payments, we would just put N equals 4. But realistically, people don't make loan payments annually. So for this example, I've decided to make monthly payments. We could have used weekly or bi-weekly, or even semi-monthly would have been a realistic assumption, but just for no real reason, I chose monthly. So N is not 4, it's 48. The future value is going to be 0. We know that because at the end of 4 years, we will have no loan left. So in 4 years' time, the balance on the loan will fully be repaid. So therefore, what are we solving for? We're trying to find out what the payment is going to be. So we'll go back to our calculator now. So the first thing that we're going to do again is check our settings. So when we're using a loan calculation, interest compounds at the end of the period. So your loan's dispersed today. For monthly payments, I wouldn't make my first payment till 1 month after, so at the end of the period. So let's just make sure, yep, we're set to end, so we're good. And I wanted monthly payments, so check my payments. They're at 12. and my compound periods are at 12, and that's just fine for a loan. It's just mortgages that are semi-monthly. So we're ready to go. Decimal places are 2. We're happy with that. So present value, $20,000. That means money is going to be dispersed to us, so it is a positive number. 20,000, and we just push the present value. That's it. The interest rate that's being charged on this is 9%. So we simply choose 9 and then press interest rate. We don't have to push enter for these. By pressing the function key, it captures it. N is 4 years or 48 months. So I could do 48 and N and enter it that way. But what if I had 17 years, and math isn't really my strong suit? So I've got it set already in the calculator that my payments per year are 12. All I need to do is do 4 second function N, and it will calculate how many months that is. However, I do have to press N again. So the two ways of doing that, I could either do 48 N to capture N, or I could do 4 second function N, and it will automatically multiply by my payment frequency, which is kind of a helpful tip in odd years if you're not great at doing math in your head. We just push the N key to make sure it's secured. And then we need to, our last variable that we're inputting is 0. So we know that 0 is going to be our future value. Then we want to solve for payment. All we do is the CPT button, which is compute. We compute, what are we looking for? Our payment. And we see that the payment for this loan would be $497.70 per month over 4 years. You'll note that this number is a negative. When you think about present value and future value calculations, you want to think about if money's coming into your pocket or going out of your pocket. This is the simplest way to remember when you need a negative. So when a loan's dispersed, money's coming into your pocket. When you're making payments, money is coming out of your pocket. When you have a 0 either in the future value or present value position, it's not so imperative to get that negative in properly. But say we had we wanted to know what the value was going to be in 2 years, so we had a positive value there, then it would be really important to make sure that you're putting your positive and negatives in the right place. And we'll look at that more when we look at other calculations. So going back into our presentation, we're going to look at a second example. So in this example, we're going to assume that we're going to start a weekly savings plan. Instead of borrowing, we're contributing. You have nothing saved so far, so present value would be 0, and you want to save $100 on a weekly basis. This is what you feel in your cash flow you're able to put aside. Your savings vehicle pays a 2% rate of return, and it compounds at the end of every month. How much do you need to save? And I'm sorry, that actually should say how much would you have saved. That's better. So if you're saving, you have nothing saved up, you're going to put $100 a week away, you get 2% compounding per month. How much would you have saved if at the end of 2 years? So 2 years from now, how much will you have accumulated with this $100 per week plus a 2% rate of return? So what are we trying to solve for, and which variables do we already know? We know that we're starting with nothing, so our present value is 0. We know that we're going to contribute, so negative money, we're going to take out of our pocket $100 a week. We know that our payment frequency is 2 years worth of weekly payments, which at 52 weeks per year is 104 payments. And we know that we're going to have a rate of return of 2%. So therefore, we're going to solve for how much we are going to have at the end of 2 years or in the future, our future value. Let's get back to our calculator. And again, first thing we're going to try, we are going to check is our settings. It's compounding at the end of the month, so we still want it at end, and that is in fact where we were. We want to have weekly payments, second function IY to get that PY. We're going to change that to 52. We're going to enter that. But if we check our compound periods, it's defaulting to match our payment, and we actually only want compounding once a month. So there's only going to be 12 compound periods per month, and we enter that. So now we've got our payments set for 52 and our compound periods set to 12, and now we can begin. So 0 is our present value. 100, and don't forget that's coming out of our pocket, so it's going to be a negative, is our payment. 2 years is our number of years, but what was our frequency? It was 52, so that will automatically compound if we second function and n, and then just remember to hit n again to enter it into your calculation, or you could have done just 104n. And 2% is our IY, and we're trying to find what the future value is. So compute the future value, and if we had saved $100 on a weekly basis, compounded monthly at 2%, in 2 years' time we would have $10,608.58. And you'll see that this would be money that we would get back into our pocket, so that is a positive. So money coming into our pocket is positive, coming out of our pocket is input as a negative. So I hope that clarified how to use the calculator. We'll be using it an awful lot in our program, so please play around with it. If you'd like some more examples to work through, just let me know on discussion boards and I can post a few with some solutions. We can try solving for what the present value would be, what the payment would be, what n would be. So if I want to save up, I can afford to save $500 a month, and I need to save $100,000, and I can get 7% rate of return. How long is it going to take me? That would be a situation where you would want to solve for n. Or if I need to save $100,000 over 20 years and I can only afford to put in $600 a month, what rate of return do I need to get? That would be solving for IY. But ordinarily we would, if we're getting a loan or a mortgage calculation, we're probably solving for the payment. And when we're doing a savings calculation, we're usually either solving for payment, so I want to have a certain amount at a certain time, how much do I have to save, or I'm putting away this at whatever projected rate of return we have, what would I have in the future. Again, hope that helps. If you have questions or concerns, please email me or send a note on the discussion. And a final thought, remember, we always first check our settings before you make your calculations.